have another problem today. We're going to try and solve the number of pairs problem that we didn't get to yesterday. Ooh, let me just close that up. Okay. I have a couple of problems now. I am dreadfully over the time limit, and it's an issue because I have the right idea. Well, the problem involved us working through some array. I'm going to draw it now. Let's say 5, 1, 2, 4, and 3. Let's sort that to 1, 2, 3, 4, and 5. And I want to find every possible pair of numbers such that the sum of them falls within a specific range. So in this example, the range is 5 to 8 inclusive. 5 to 8 inclusive, and then yeah, so pretty much for some value we need to find all other values that, well, we can split it up into two parts actually. So say for 8, so say I can sum up 1 and any of these numbers and they will be smaller than or equal to 8. But then we have to consider 5, and then we have to do the same thing for 5 and say, okay, for which numbers will the sum of 1 and x be smaller than 5, because it's inclusive. So anything smaller than or equal to 3 will give me an invalid sum. So we'll get a right pointer on the 5, and we'll get a left pointer on the 3. The difference between them is 2, and that gives me two possible pairs given that 1 is one of the values. We do the same thing for 2 with the values in front of it. In that case it would be all 3 of them. For 3 it would just be 4, yeah? And then for 4 there would be no valid pair. And then for 5 of course no valid pair. So it's possible because we binary search. We binary search for upper bound and lower bound, and yeah, like that's really just the problem. I mean, we had the right idea yesterday, but let's say we got tired. Let's say that yeah, because we are wearing these the whole day. But let's say we were tired and we just didn't see it. But now we do. Now we do. My problem is that sorting takes way too long. It takes stupidly long. And I'm exceeding the time limit on test 7. Test 7 is right there. Okay, it's literally just got one test, and that just breaks our program. But it did work for a similar one. But what changed? Oh no, it doubled the number of elements. Okay, so sorting is the issue. I'm 100% certain. Okay, so let's find a fast way to sort. So sort array Java. Okay, let's see. So they want us to take into account duplicates. Bucket sort. Okay, that might be a bit too overkill for this problem. Stack abuse. I hope this is working. Yeah. What is the time complexity of array sort though? N log n. How are you going to sort in O of n though? O of n memory, O of n log n time. It can't be sorted any faster than n log n. Well then what? Because I mean, where else are we leaking memory? Not memory, time. I mean, would it be faster to place an element in the correct position once we read it in, or would it be faster to sort it all at once? It's like, it wouldn't make sense we wouldn't be able to use a tree set or a priority queue because we need to access each element individually. Each specific element, I mean. Because it's the sort that's taking the majority of our time, and I don't know how to counter that. I mean, there was even another 200,000 sized array, and it handled it well. So that says something. I mean, in this scenario, they were probably look at the number of pairs there were. But then they give us this scuffed example. I think it's time we check some solutions, friends. Let's analyze something. At least I wasn't the only one that struggled with it. About 7,000 people fell off from there. Okay. Let's see this pink. This pink has a long time. Wait, how did it use no memory? Okay, you need to have some really big array. You read everything in. Okay, you sort it with regular sort. Maybe you have a custom sort. No, it's a regular sort. Low is equal to n, high is equal to n. Or is she using? Why am I saying she is this person using 2-pointer? I have no idea how this is fast enough. She's going through every... Why am I assuming this person is a woman? Wait. I'm losing my mind again. That's what problem I saw yesterday. That's cool. Okay. That's all she's doing. She's saying for some element at n starting from 0, I'm going to check all the possible pairs and ties a value to it, low and high, and then we just get the difference between those two values such that it creates a bound where the sum is within a range. So there's a couple things we can do now. I'm gonna see, wait, where did, okay, pink. And wait, how fast was the test 7 anyway? 280. But you're sorting it like all of us, like the rest of us. But we're doing the same thing. We're finding an upper bound, we're finding a lower bound. And you have an extra condition. Okay, but let's try to implement this. If this is slower, fair play. I've got nothing to tell you. Just kind of bothersome sometimes. So we read it in, we sort it, we have a total count. We need low and high. Okay, and then low. It's just going to equal n, I believe. Yeah? Yeah, n minus 1. And then we need to store the initial value. Then we need to run 2 while loops, and then while low is greater than 0, greater than or equal to 0. No, it has to be greater than 0. We're never going to have that case. And r low plus a is greater than or equal to L. Yeah, then we can say low minus minus, and then while high is greater than 0. High is greater than 0, and then r high plus a greater than r. Then we can say high minus minus. Then we'll have some range, and then we can say, well, I mean, it could be more efficient to then to do high first. If we do high first, then we start low from high minus 1, so that we don't have to waste our time checking those values. But let's see if this works first of all. So let's see, total plus equal high minus low. Yeah, that I don't need to minus 1 because I'm subtracting even if it's equal to L. Okay, she had an extra case, but I don't understand why. So let's see what happens here. So here, print line, yeah, total, it's already there. Okay, I've sorted it. Let's have a look see again. Oh, we're double counting. Yeah, we just divided at the end. So the total divide equal to, because we're not limiting it to I smaller than or equal to j. So there's a lot of inefficiencies in this. So I think that might be fun. We might just try to optimize this. But for now, we're not even getting it right. 2701. Okay, so we're just missing one on those guys. Okay, so let's just make sure on paper what we're doing. Oh, so I understand what that statement was for now. Okay. So then if R smaller than A and R and A is smaller than R high, then we know that we've made a pair with the same number. So we have to get rid of that. But we're still counting under, which I don't understand. Yeah, I think I'm suspecting. Okay. So the max value is 10 to the power of 9. It's going to say Rn to 10, 9 plus 1. And these guys initially get n. Now we get 6 instead of 7. Man, you know it's bad when you can't even copy correctly. This is crazy. I used to be able to rip through these problems. Oh, that's probably stupid. Wait. Wait. Just wait a minute. That's not going to change anything, is it? Where have I gone so horribly wrong? Where? I like the solution, it's just not fast. And I feel like, wait, it is not fast, it's not. Surely it's not. Yeah, no way. Yeah, no, it's not fast. But it works. So I won't say too much. I mean, what can I say? I'm just gonna fumble. Wow! Come on. 1601. Time to debug, I think. Wait, or no, then let's just look at it again. Are low smaller than or equal to A? Or rather if low. Wait. Can be somewhat misleading, I think. Wait. Huh. Why? Let me just submit it and see what I get wrong. Wait. Yeah, there should be a wrong answer. Okay. There's 2? Okay. So that must stay. But I'm doing something wrong with the overcounting, I think. So let's just put a bunch of debug statements. Let's see what happens. Total is long as well. Oh, this is the small sample. I got 1 for that as well. So let's see what happens. So the range is 4 to 7. So it should go down 1. Low is 3. Greater than or equal to L. If int a is equal to ri, sure, that's true. And then if a plus, in our case 5, greater than or equal to L, it has to minus, but it didn't minus. That's true, but it didn't minus. Why? Our L is 4. And 1 plus 5 is greater than or equal to 4. Debug again. Okay, so now we're going to try to make this a bit more efficient. Okay, how? You know what? I think, okay, so this solution has like this double counting principle, and I don't want to change that because it works. But what I don't get is why mine didn't work initially. It makes no sense.
If it ain't broke, don't fix it.
Hey man, it sucks. The solution sucks. I used so it's kind of like, say you have a dictionary, right? Say you're looking for the word furry.
Yeah.
You open the book, bruh. You go to you find bobcat. You're not gonna check every single word from bobcat up to furry. You're just gonna keep opening it until you get closer to F. So that's what my solution did. So this one's checking literally every word until furry. But
I see.
But it somehow works, and mine didn't. So I'm very mad. But I understand.
Don't be mad.
So it's fine. It's fine. It's fine. So I think that's all I'm gonna do for today. I'm just gonna close this up now.
Thank you, my mother.
Yeah. Put up a nice little one there.
Update on the survival world.
That's all for today, man.
Iron.
That's all for today.
How long do you code every day? What does it depend?
Today I was doing maths in the morning because the maths homework that we have. So I from the last day of school. So I did that and I finished it.